Hello everyone. In this video, we will try to construct full adder circuit using NAND gate and also with the help of IC7400. So for doing this experiment, we need apparatus like NAND gate. At least 9 NAND gate are required because in order to make a full adder circuit, we required 9 NAND gate and 2 switches, basically 3 switches and a DC voltage supply and 2 LED bulb for sum bit for representation of sum bit and carry bit. Let's explore a bit about the full adder. So full adder circuit is basically a combinational circuit that perform arithmetic sum of input. It consists of mainly 3 inputs and 2 output, and this can be realized with the help of XOR gate and AND gate. So this is the logic diagram of full adder circuit in which we use 3 input A, B, C, and it has 2 output. One is sum bit and another is carry bit, and this is realized with the help of 2 XOR gate and 2 NAND gate and 1 OR gate. But we can also realize it with the help of NAND gate, which is our basic aim. So for realization with the NAND gate, we required 9 NAND gate. So let's make this circuit and let's verify the truth table. So let's start with the connection. First of all, we will connect the output coming from the switch A to the one of the terminal of NAND gate 1 and second input terminal and output coming from the B to the second terminal of NAND gate 1. Now output of first NAND gate is connected to the one of the terminal of second NAND gate, and the same output is connected to the one of the terminal of second NAND gate. Now we will connect signal A to the one of the terminal of second NAND gate, and we will connect signal B to the one of another terminal of NAND gate 3, as we have performed in the half adder circuit. Basically, for making a full adder circuit, we require 2 half adder circuits. So we will construct and also verify it. Now the output of second NAND gate and third NAND gate is connected to the terminals of fourth NAND gate. So this is the basic configuration of our half adder for giving the sum bit. This is the half part of our adder circuit. Let's make a same copy of this again. So treating this as a first NAND gate, we will connect output of this first NAND gate to the input of second NAND gate, and the same common output is connected to the one of the terminal of the third NAND gate, and the input signal that is coming from the first NAND gate is common to the second terminal of third NAND gate and second terminal of second NAND gate. And now the output of the second and third NAND gate is connected with the terminals of fourth NAND gate. So this is the configuration of two half adder circuit. This is the first half and this is the second half. Now we are connecting both of them for providing configuration of full adder. Now we are connecting the output of the fourth NAND gate with the one of the terminal of the fifth NAND gate, and at this point we will connect the input, third input, that is C. Now this is the sum bit configuration for the ladder. Now we will connect the output to the one of the terminals of LED, and second terminal of LED is connected to the ground. So we have performed the connection for our sum bit. Now for carry bit, we will take one of the common output from the output of first NAND gate and output from the fifth NAND gate and connect it with the terminals of this NAND gate. So for performing this connection, we will draw two terminals on the output coming from first NAND gate and output coming from the fifth NAND gate, and we will connect it to the terminals of the ninth NAND gate. Now the output of this NAND gate is connected to the one of the terminal of LED bulb, and second terminal is grounded. So this is the basic connection of our full adder circuit using NAND gate. Now we will verify this connection for our truth table. So let's perform this. But before that, let us copy the truth table over this sheet. So this is the truth table for our full adder. Now we will verify this truth table with this connection, or basically we will verify our connection with the help of this truth table. So basically A, B, C are three input terminals which are which are controlled by switch S1, S2 and S3, and carry and some bit are represented by this bulbs. So let us start. So for the 0 0 0 case, means when A, B, C all three are 0, then we will get carry bit 0 as LED is not glowing, and some bit also 0 as this LED is also not glowing. Now for the second case, A is 0, B is 0 and C is 1. So as soon as we will switch on the C button, we will get the sum bit as a 1, which is easily indicated by glowing bulb. Now for third case, we will keep switch second open, and first and third switch will be remain open and second switch will be closed. So in this case also we will get a sum bit but not a carry bit. Now for the next case, we will switch on B and C switches, and we will get one carry bit but zero sum bit. So as soon as we will close the both switches, we will get output as a sum. Now for the next case, we will close the switch B and C, and we will see that carry bit will 1 and sum will be 0. So as soon as we will close both the switches, carry bit will be 1 and sum will be 0. Now for the next case, we will just close the first switch and open second and third switch. So in this case, we will get only a sum bit, not carry bit. So it is again verified. Now we will verify for closing last case, that is switching on all three switches. So in this case, we will get carry as well as sum bit. So as soon as we will close all three switches, we will get one sum and one carry. It means 1 plus 1 plus 1 in binary algebra, we will get one sum bit plus one carry bit. So in this way we verified our truth table. Now we will perform the same connection with the help of IC7400. So in this case also we will have three input terminals, and for that we will use uh, 3 IC, because we require 9 NAND gate, and in one IC7400 there are 4 NAND gates. So in order to get 9 NAND gate, we require 3 ICs. So we will connect it very slowly and very step by step, because connection is quite meshy. But let's start the connection. So for this, first of all, we will connect the input signal A to the first NAND gate 1A. Now we will connect the second input signal to the second input of first NAND gate, that is 1B. Now in as we can take the one input from the B and one input from the A and connect it to the one of the terminal of second NAND gate and one of the terminal of third NAND gate. So let us create the junction on A and B. We will connect one of the terminal to the second NAND gate and another terminal to the one of the end of third NAND gate. Now the output of first NAND gate is common in the input of second NAND gate and third NAND gate. So we will connect it to the second NAND gate, and the same output is common in the third NAND gate, the input of third NAND gate. Now the output of the second NAND gate and third NAND gate is connected to the input of fourth NAND gate, as we have performed the same type of connection for our half adder circuit to the one of the terminal of fourth NAND gate. And now we will connect the output of the third NAND gate to the input of the fourth NAND gate. Now the output of the fourth NAND gate is act as a sum bit for our half adder. So we will put the same output in the second half adder connection. So before connecting that, first of all we will make a connection of the second half of second half adder on this IC. But before that we will connect the ground terminal 7 to the ground. Now we will connect for the second half of half adder. Now for this also we will connect the input coming from the first terminal to the one of the terminal of second NAND gate, and the input coming from the second terminal is connected to the one of the input terminal of third NAND gate, and output coming from the first NAND gate is remain common in one of the terminal of second NAND gate and one of the terminal of third NAND gate. Now, now output of the second NAND gate is connected to the one of the input terminal of fourth NAND gate, and output of third NAND gate is connected to the second input terminal of fourth NAND gate. Now this output coming from the fourth NAND gate will act as a sum bit, which is connected to the one of the terminal of LED bulb, and second terminal of LED bulb is connected to the ground. So this action is performed for, or basically this connection is performed for the sum. Now we will connect the both half adder to make it full adder, but before that we will connect the pin 7, that is to the ground, and pin 14 to the positive supply. Now as we have the output 4Y, that is for the first half adder is connected to the A terminal, and I'm changing color of this wire in order to differentiate it from other. And the C signal is connected to the 1B. Again I am changing the color of this wire. So we have performed the connection for the sum bit. Now for the carry bit we will connect the output, that is, let's refer to earlier diagram, that for the sum carry bit we will connect one of the terminal coming out, that is the output of the first NAND gate, and second is that is output of the fifth NAND gate. So in the this connection also the output of the first NAND gate, that is Y1, is connected to the one of the terminal of the NAND gate input terminal, and Y5, that is the Y1, this connection is connected to the second terminal of this NAND gate, and the output coming from the NAND gate is act as a carry bit, which is connected to the one of the terminal of LED, and second terminal of LED is connected to the ground. Now let us connect the 7th pin of IC with the ground and 14th pin with the positive supply of 5 volt. So this is the connection for the full adder. Now we will verify for the truth table, that is we can easily construct it mathematically also, as this representing zero signal, open switches are representing the zero signal, and closed switches will represent open signal. So if we add 0 plus 1, then sum as a 1, and if we will add 1 plus 0, then also it will give sum as 0 and carry as, sorry, sum as 1 and carry as 0. Now if we add 0 0 1 1 and 1, then we will get sum 1 as well as carry bit 1. So this is the simple verification of our truth table. We can verify other cases too. as verified earlier. So basically this is the connection for our full adder circuit. Thank you.